We're going to start today's lesson talking about lines, pairs of lines, and then we will finish by talking about angles. Some of this will probably be review, but I have some new notation that maybe you don't know about. Parallel lines, two lines in the same plane that do not intersect. You know what parallel means. What I want to show you is how we mark lines parallel. We can't use tick tick because that would mean congruent, and lines are infinitely long, so that wouldn't make sense. But for parallel, what we're going to do is we're going to use little triangles. And if you see two little triangles on a set of lines, that would mean they're parallel. And if you had a different set in the same picture, you might use double arrows on those. But little triangles on there means parallel lines. And if this was line A and this was line B, and I want to write that A was parallel to B, I could use this notation: A parallel to B. Perpendicular lines, we've done a little more of that. Two lines that intersect to form a right angle. And we know that the notation for that would just be probably having a right angle symbol somewhere in there, right? And if this were a line A and a line B, we've already learned the symbol for that. A is perpendicular to B. Skew lines. This is probably new to you. Skew lines are two lines not in the same plane. It turns out that any two lines that I would draw on a piece of paper would be in the same plane, whether they were parallel or perpendicular or neither of those. But this is talking about more 3D types, so let me give you a drawing for that. So let's say this is a line right here. Any other line that I put either on the front of this box or even on the bottom of this box would be considered in the same plane. If I put a line right here, we could actually make a plane that sort of slants up through the box, and those would still be on the same plane, just on a slanty plane that's not drawn. So how do I draw two lines that you cannot put in the same plane? Here's how. What if I looked at this line right here? If I tried to make a flat surface that would connect those, it would have to be almost like a curvy surface. And this is easier to explain in person, but in this video, you would almost have to use sort of a twisty plane. And planes aren't twisty, planes are flat. Skew actually sometimes means twisted. If you have like a skewed view on life, that means that you think about it in sort of a twisted, different way. So skew sort of means twisted. I have another definition for skew that will work for us. Skew lines will never intersect. Once they intersect, that means that they're on the same plane. But they're also not parallel. But I think we could agree that this line and this line don't appear to be parallel to one another. This one's vertical and that one's horizontal. And so those are not parallel. So we have a new word to describe those, and we would call them skew lines. They don't intersect, but we would not call them parallel. Unfortunately, there's no real symbol for A is skewed to B. I feel like we should make up a new symbol for that, but I don't know one, and so we'll just have to use the word skew. In this example, we're going to talk a lot about line AF up here, just imagining that that would extend on forever. So the top edge of this little prism, we are going to try to find some lines that are parallel to AF and contain point E. To be parallel, I feel like we would need to go through EJ. What do you think? Does that look like that would be parallel? So I would say line EJ would be parallel to AF and definitely contains point E. Let's practice our new understanding of skew. Skew to AF and going through E. So EJ was in the same plane as AF, so those wouldn't be skew. We're going to need to look for a line that's sort of twisted and not intersecting. I think I would go with this line right here. Do you see how line ED, even if it went infinitely, and you have to sort of think 3D about this, it would miss line AF. It would kind of be out in front of line AF. So line ED does not intersect line AF, but we also would not call them parallel to one another. They're in totally different planes. Next, I'm looking for a line that's perpendicular to AF and containing point E. Now, I think if I were asking this question, I would probably ask about any lines that appear perpendicular, because I certainly don't see any right angles drawn on here. So perpendicular would mean intersecting at a right angle. I would think that if this box were structured the way that it seems like it would be structured, don't you feel like this little side right here would be a rectangle? And rectangles have those right angles in the corner. So I would prefer that there be a right angle symbol right there. But if I wanted to look for lines that appear perpendicular, I would say line AE. This one's asking about finding a plane that's parallel to plane FGH. And plane FGH is this pentagon in the back. And we're looking for another plane that's parallel to that plane that goes through point E. And if this is a true prism, it would just be this other pentagon that represents a flat surface that would be parallel to that back plane. And what do we call that front plane? We would pick any 3 points on that plane that form a triangle. So I might just call it plane A, B, C. Any 3 points would work though. If you feel like you need more practice with this, why don't you just pause right now and see if you can answer these 4 questions. And here are the answers that I came up with. Let me know if you have any questions. Here's a little challenge for you. I have a line drawn and a point. If I asked you to draw a line through that point that's parallel to the given line, how would you draw that? Something like this? Now, what if I challenged you to draw another line that's also parallel to the green line that also goes through that point? Could we draw another line? To me, I feel like any line that I draw that goes through that point and is parallel to the green line, I feel like there's really only one line that I can draw like that. The same thing applies to a perpendicular line. If I asked you to draw a line that's perpendicular to the green line that goes through a certain point, can you draw more than one of those? Well, if I require you to go through that point every time and make it perpendicular, there's really no other choice. And that example just shows 2 really basic postulates of our geometry. If there's a line and a point not on the line, then there's only one line through the given point parallel to the given line. That's called the parallel postulate. The perpendicular postulate, if there's a line and a point not on the line, then there's only one line through the point perpendicular to the given line. When I took geometry in college, it turns out that those postulates aren't always true, not in every type of geometry. There's another type of geometry, sometimes called spherical geometry, where those postulates aren't even true. Do you want to hear about it? In spherical geometry, lines can't really be straight because they're on a globe, they're on a sphere. So we would think of lines of longitude as being lines. We would call that a line. Lines are almost like rubber bands that are wrapped around the circumference of the globe. And so if I had a line and a point not on the line, how many parallels can I draw? The answer winds up being really none, because as soon as I try to draw a line of longitude, do you see how they intersect? And even if we allow for going around the globe sort of in a slanty way, you wind up intersecting. And so the parallel postulate winds up being that there are no parallel lines in spherical geometry. For the perpendicular postulate, it turns out that I could wrap a rubber band around the globe in a perpendicular way in lots of different fashions. So I don't know if you can picture this, but the idea is that I would be able to wrap a rubber band around the globe and make lots of different perpendicular lines. So the perpendicular postulate would say there's infinitely many perpendicular lines through that point. So just some fun facts about a different type of geometry, but in our geometry, planes are flat and lines are straight, so we won't have to think about that. All right, this diagram actually has some good markings on it. Can you find me a pair of parallel lines? The parallel lines I'm seeing have those little triangles marked on them. So my pair of parallel lines, remember I used 2 points to name a line, so I would say that line AB is parallel to line CD. Where's my perpendicular? That's my right angle that it forms. So which two lines form a right angle? I would say line AC is perpendicular to line AB. And now the question, is line AB perpendicular to BC? Is line AB perpendicular to BC? The question is, do they intersect to form a right angle? I'm going to go with no on this one. That's not looking like a right angle. None of those are looking like right angles. So I would say no, and my explanation would be they don't intersect to form a right angle. I promised you we'd talk about angles in this section too, so here we go. Angles formed by transversals. Transversal just means to cross. So in these diagrams you'll see two lines that are crossed by another line, and that line is called the transversal. And you'll notice that there's 1, 2, 3, 4, 5, 6, 7, 8 little angles that are formed by that transversal. And certain pairs of angles have special names. And so angle 2 and angle 6, do you see how they're both in sort of the upper right corner of those intersections? Those are called corresponding angles. It could also be the two angles that are in the upper left corner, or the lower left, or even the lower right. We would have 4 pairs of corresponding angles in this picture. Corresponding angles just mean that they relatively have the same position. The other types of angles we talk about are going to distinguish between interior and exterior. Interior means on the inside, and they're talking about those two lines that get crossed. So that yellow part would be considered the interior, and the exterior would be outside of those two lines. So interior, exterior. And this special pair of angles is called alternate interior angles. So we would be looking at the angles that are on the interior. That would be these 4 angles. But we'd be looking for a pair that are on alternate sides of the transversal. That's where the word alternate comes from. So alternate interior would be this angle 4 from the top line and the angle 5 from the bottom line. Those two angles would be considered alternate interior. We'd have one more pair right here and right here. Those are still interior angles, and they're on alternate or opposite sides of the transversal. Do you think it helps to color code the interior versus the exterior on these? I'll color that in for you. Because this next set is called alternate exterior angles. So both of these angles are going to be in the exterior, one on one of the lines and the other on the other line, and alternate meaning they're on opposite sides of the transversal. On this picture, our other pair of alternate exterior angles would be this one and this one. This type is called consecutive interior. Again, both angles are on the interior. Consecutive meaning 2 in a row. Notice it doesn't say alternate, so they're on the same side of the transversal. In fact, sometimes some people, instead of calling these consecutive interior angles, call them same side interior angles. That's how I learned it when I was a kid, so I might use that term a little bit more. We would have another pair on this picture that would be same side interior or consecutive interior. The two angles that are on the other side of the transversal, but they are on the same side of the transversal. This last example definitely looks a little bit difficult because there's those 3 lines and they're all intersecting each other. So which one is even the transversal? Well, since they have those angles numbered, I'm thinking that this must be the transversal since all of those angles depend on that line. So in that case, these would be the 2 lines that we would determine interior and exterior from. Interior meaning between those 2 lines, and exterior meaning outside. So let's go through each of these pairs and see if we can decide what type of angles they are. Angle 1 and angle 2. One's interior, one's exterior. This is tricky because that's an old one that we knew before. That's just a linear pair. It didn't even require the use of this line at all. So that's just an old review one. Angle 1 and angle 3. I noticed that angle 1 and angle 3 are both in sort of the upper left-hand corner of their intersection. Do you remember what we call that when they're in sort of the same position, both in the upper left? That's called corresponding. Angle 1 and 5, both exterior, and they are on opposite sides of the transversal. Let me label that transversal T. But even though they're on opposite sides, again, it didn't even require the use of this other line. So that's just a regular old linear pair. Angle 1 and 6, kind of the same feel. There's one interior and one exterior, but since it only relies on two lines intersecting, just the transversal and one of those lines, do you recognize those as vertical angles? Finally, we get to angle 1 and angle 8. Angle 1 and 8 are both on the exterior, and they're on opposite sides of the transversal, and they do require those two lines that separate interior from exterior. So 1 and 8 are alternate exterior angles. How about 2 and 3? 2 and 3 are both on the interior, on the same side of the transversal, so we would call those consecutive interior or same side interior. Your choice. Angle 2 and angle 4. I would classify those as both sort of being in the upper right corner of their intersection. So they're both in the sort of the same position. We call those corresponding. You'll also notice that corresponding angles always have one that's interior and one that's exterior. Angle 2 and angle 5. One's in, one's exterior, but those are just vertical angles. Now we've got 2 and 6 and 2 and 7. Can you tell which one is which? Well, 2 and 6 are on opposite sides of the transversal, but so are 2 and 7. So which ones would we call alternate interior? We use the term alternate interior when we're talking about these two lines being cut by a transversal. So the 2 and the 7 would be considered our alternate interior. And you probably recognize that angle 2 and angle 6 are a linear pair.